Good afternoon and welcome from the Black Forest in Germany. Welcome to another live demonstration, this time about liquid food. My name is Rob Smulders and I'm Business Development Manager for VEGA Netherlands.
Welcome to VEGA Live. My name is Julian. I'm an International Area Sales Manager for Asia and Pacific, based here in the headquarters in Germany. So Rob, let's start.
Let's start. Well, today we're going to speak about applications in the brewery and the liquid food industry. And VEGA is specialist for level, pressure and point level measurements. And of course, we're going to show you some of the applications in which you can use our devices. And we're also going to do live demonstrations, which is always quite exciting for us because, of course, during live demonstrations, things can go wrong and sometimes they will go wrong. But Julian, can you show us some applications about level measurements?
Sure. Typical applications here in the liquid food industry, for example, is a purified water tank. You can see here several types of measurement technology. On the one hand side, here pressure sensors are installed on top as a gas pressure measurement or also inside the pipes. Pressure sensors could be also used at the bottom as a level measurement. Here we need a density as an additional information. However, what is very common right now in the industry is that we are using a radar sensor at the top of the tank, so it's a contactless measurement with an easy installation. However, what you can see inside liquid food application, we have here spray balls, so water is turning inside the tank, or when we talk about creamy applications like jam or chocolate cream, of course build-up can occur. However, our VEGA Pulse 64 or 80 GHz technology for radar is very independent from build-up and condensation. And with our very first live demonstration, Rob wants to show you that our radars are independent from these application conditions.
Yes,
Rob?
yes, definitely. Thank you. We have a small setup over here with a VEGA Pulse 64 80 GHz radar instrument and a display unit displaying the distance from the sensor to the ceiling. Usually they're mounted the other way around, so you measure from the top to the liquid level, but here we measure up to the ceiling. It is connected to a VEGA Mat, a display unit showing 2 meters and 18 centimeters up to the ceiling. Should I lift the device, you will see that it is constantly measuring and the value will go down, similar as when we would fill the vessel. The antenna surface, the part which is actually inside of the vessel, is made of PTFE, which is a really smooth surface and it has no edges, so it will be easy to clean. Another thing is a lot of the water or condensate which will be on the antenna will drip off because of the way that the antenna is made. But we can show you what will happen when we put a lot of condensation on top of the antenna system. I have a water bottle over here, and what I'm going to do now is spray the top of the antenna, and we will see via the display unit if this will have any effect on the measuring of the sensor. So I'm going to try to make it as wet as possible, and you can probably see that the water is already running off. Should it be upside down, the water will drip off the antenna system immediately. And the measurement value of the VEGA Pulse was still the same, no problem whatsoever.
Thank you, Rob, for showing us the condensation. What else do we have is, I have some chocolate cream with me, so we can show you also additionally that our sensors are independent from build-up. So Rob, I will hand over to you the chocolate cream and looking forward to the next demonstration.
Yes, probably well known from breakfast, chocolate cream. It could also have been jelly or honey, which is shown here on the screen. Should we get buildup from such a product on top of the antenna, it's interesting, and you have to know that if your radar sensor will keep on measuring the accurate level, and we're going to try that. I'm going to smear some chocolate on top of the antenna system. As you can see, there is absolutely no effect on the measuring itself. And just to show that the sensor is still active, I'm going to lift it up, and what you will see is that the measuring value is constantly changing. So I think this proves that build-up or condensate on top of the antenna system will have no effect on the radar whatsoever.
Thank you, Rob, for demonstrating that here with the live demonstration. Here in the back you see our VEGA Pulse 60 series, especially our VEGA Pulse 64. These are our sensors for high demanding applications in the liquid food applications. We have here all kind of approvals and different kind of process connections, like here a clamp version. If you need less demanding applications, the new VEGA Pulse 10 to 30 series can be also used. Here we are limited in temperature ranges and also in approvals in general, but for easy applications they are also doing the job very well. Of course, you can see here we have a G1.5 thread inch connections, but Rob will show you also that there's a possibility to adapt this to a hygienic application.
Yes, as you can see, the 1.5G threaded connection isn't a connection which is used very often in the food and beverage industry. But by using these adapters, which we have in several different configurations, like this one, which is a 11851 configuration, but also in clamp configurations, you can change the G1.5 inch connection to a more industry standard connection for the food and beverage industry. So I think this is a really nice solution to get a more industry standard device from the 10 to 30 series radar sensors.
Great, thanks. This was it about the radar sensors and the level instrumentation of VEGA in the liquid food industry. Again, we also have pressure instrumentation in our portfolio, what you can see here in a brewery application. Here on the bottom, you see a pressure sensor measuring via the density the level of this tank. However, since there is an overpressure in the tank, we need an additional pressure sensor in order to create an electronic differential pressure system to get the real level. Of course, inside the pipes, pressure instrumentation can be also used. Coming to the differential pressure system, what we are using here, we can show you with this small model that we have two types of differential pressure systems. Here you can see an electronic differential pressure system. So two single pressure devices are mounted on top and on the bottom and are only connected with an electrical cable. The main advantage is here that we have an easier setup and installation in general. And we don't have any temperature influences on the outside of the ambient temperature. On the other hand, we have here the classic differential pressure system. So here just one device is connected to two chemical seals, which is measuring the differential pressure. Main advantage is here that we have, even though we have a high static pressure, so a high overpressure in the tank, we still have a very accurate measurement. However, the capillaries do have a temperature influence from ambient temperatures, which we have to take into account. So in general, we have two systems for differential pressure. Rob, however, there's also for our normal pressure sensors two different kind of measuring cells.
Yes, there are. Two different kinds. You have a metal measuring cell and a ceramic measuring cell, both of which have their advantages and both of which have their, let's say, disadvantages. To start with, a VEGA bar 83 in this case with a metal cell. And a nice thing to know is all our pressure sensors which end in an uneven number are metallic cells. If they end in an even number, they're ceramic cells. So an 83 or a 39 are metallic cells. One of the big advantages of this metallic cell for food and beverage industry is that they have a welded connection between the process and the membrane, which is actually the wetted part. So there are no seals or no edges in between. This is a big advantage to keep your application hygienic. The disadvantage of this is you need a metallic membrane which is pretty fragile. It's easily damaged when it's hit with a sharp object, for example, or when you have abrasive material in your tank, like jelly with nuts or something like that. So that's one of the disadvantages of a metallic measuring cell. So coming to the ceramic measuring cell, in this case a bar 82, an even number, so a ceramic measuring cell. Here we do have an elastomer between the ceramic measuring cell and the metallic process connection, because it's impossible to connect these to each other. The big advantage of the ceramic measuring cell is that it's really robust. It's robust for abrasive materials, and it's also robust for pressure shocks. So those two things are a definite advantage of this ceramic measuring cell. And I think we can show this with the two models we have over here. First, I'm going to walk to the abrasiveness test, which we also call the torture room for measuring cells. In this model, we have a ceramic measuring cell, a pressure sensor mounted at the bottom of a tank. So this in our model is the tank with a ceramic measuring cell placed in here. And I can show you that the ceramic measuring cell is measuring really nice. If I give some pressure to the measuring cell, you see the value changing. So we have some devices over here to give the measuring cell a run for its money. We have an abrasive pad over here, which you can use to, for example, grind a little paint. Should I use this on the measuring cell, you will most likely see that the value is changing because I exert some pressure on the cell, but when I leave the measuring cell alone, it'll return to its normal state and nothing has happened to the measuring cell. I can make it even a little bit worse with this dishwashing brush, which is made from very hard plastic fibers. And should I use this on the measuring cell, I think if I would do this on a metallic cell, it would definitely be damaged and you would have to replace the measuring cell. But in case of the ceramic measuring cell, nothing happens. To make it even worse, and I wouldn't recommend this to do it with your own pressure device, but using a steel brush, I can even use the steel brush to scrape the measuring cell and to really torture it, and you will see that the measuring cell is still intact. And definitely if you would do this with a metallic cell, it would be ruined. So I think this proves that abrasiveness does not have any effect on our ceramic measuring cells. But we said abrasiveness, and as a second thing we said overpressure. And I think, Julian, you can give a little bit of overpressure to the cell.
Yes, sure. We have another live demonstration for showing that our ceramic cell is very robust now in terms of overpressure or pressure peaks. We have mounted here VEGA bar 38 with a ceramic cell, of course, mounted here to that pressure device. So if I put here that knob, air will be compressed, and as soon as the measuring range of the sensor is overturned, it will blink red. To create here a pressure peak, so pressure shock, like when a valve is suddenly opening, I can press here with a small hammer on top of that live demonstration. You can see here also a manometer connected. So this shows how big the pressure shock was in total. So let's give it a try here. Okay, this was rather a small one with just 10 to 20 bars. Try it again. Yeah, again 20, 25 bars. And as you can see with the pressure shock, the sensor is still working. However, it was just a small hammer. Of course, we have here something bigger prepared for having a big pressure shock. Yeah, so 110 bar. I give it a try once again. Maybe I break the record here internally. Still 110 bars. To show you that it is still working, the sensor, they're not affected. Sensor is working. So as a result, our sensor is very robust, ceramic cell, against pressure shocks for when a valve is suddenly opening, and also if there's buildup and abrasive media. Rob?
Yes. So you didn't break the record. We had 150 today, so perhaps next time. Here in the back we have some of the pressure devices which VEGA can deliver to you. On the left you have our VEGA bar Series 80, which is a fully customizable sensor. And what do we mean with fully customizable? For example, there are over 500 different process connections available for these sensors. So you can customize it specifically to the process. Also, the housing, if you want to have a one chamber, a two chamber, the material of the housing, all those things can be selected for yourself. On the other side, we have our more standard pressure sensor, starting with the VEGA bar 10 series, which is really a standard sensor, mostly used in machine building applications. These aren't customizable after you order them. So if you order them, for example, as a 1 to 10 bar sensor, it will always be a 1 to 10 bar sensors. Next to it, we have our VEGA bar 20 series and our VEGA bar 30 series, which is the version with the display. And those are the versions which you can adjust via Bluetooth. So the sensors have Bluetooth on board, and with the Bluetooth connectivity you can alter the sensors even after you have ordered them. So you can make them really specific for your application. And also one of the advantages of those two sensors is that they are also available as pressure switch, while these two are only available as a pressure sensor.
So again, that was our portfolio for pressure instrumentation. What is still missing?
Point level.
Point level. Okay, let's have a quick look on one application. Here on a filter, again we see here an electronic differential pressure system, but in that small tank you see mounted our VEGA point sensor, which are capacitance sensors, which are installed as a low and as a high alarm. Generally at VEGA we divide between two types of measurement technology. First of all, we have our VEGA Swing series. VEGA Swing series, this is a vibrating fork system. So this fork here is vibrating. As soon as it touches the media, it gives us an output signal. Additionally, the other type of measurement technology is a capacitance sensor. So here the tip recognizes as soon as a conductive media is touching, and this gives us an output. Of course, also non-conductive media can be measured. Very interesting here is that also differentiation between oil and water can be done inside an application. However, again, since in the liquid food industry lots of times there's buildup, we want to show you again how both technologies perform when it comes to buildup. Rob, I hand over to you.
Yes, this is one of my favorite demonstrations because I can make a little bit of a mess. We have a demonstration model over here. I'm going to show it to you what we have built into this model. At the bottom we have a VEGA Swing, the vibrating fork which Julian was just speaking about, sticking into the process. On this side we have the VEGA point 21 with the peak insert inside of the vessel. And on the other side we have the VEGA point 24, which is mounted completely flush to the side of the wall. So what are we going to do now? Should I have filled this vessel with water, for example, all three measuring devices would give a high level alarm, and when the level would decrease, you will get a low, it will lose the high level switch. This because there will be no buildup and it's an easy application. But in the food and beverage, as Julian also already mentioned, buildup definitely can occur. And we have some mustard over here, which I'm going to put into this device to show you what will happen when we have buildup on the sensors and which of the sensors will switch correctly when the level rises and when the level decreases. So let's put some mustard in here. And like I said, I like making a mess. So let's see. All of these devices are uncovered at this moment, indicated by the yellow color on these two sensors, and there's no switch point on this sensor. So I'm going to increase the level, if it'll let me, yes. So I'm going to increase the level, and you will see the color went from yellow to green for these two sensors, and this sensor is also covered. I can show you like this. So all sensors are covered with mustard. So now we're going to decrease the level again, and we will see which of the sensors will switch back to an uncovered state. Well, as you can see, the VEGA point 21 is affected by the buildup and still stays in a covered state, as well as the VEGA Swing, which is also still in a covered state. The VEGA point 24, which is really robust against buildup, switched back from a covered to an uncovered state, even though it has a lot of buildup on the sensor itself. So what do we want to say with this application? Yes, we have the sensors for sticky media, but please be careful and contact your VEGA support to select the right sensor for your application.
Thank you, Rob, for showing that how our sensor technologies perform during build-up. As a summary, our portfolio for the capacitance and also for the VEGA swing, we have here the VEGA Point 11, which is our easiest sensor, the VEGA Point 21, as well as the VEGA Point 23. The VEGA Point 23, as shown before, is very robust against build-up, and the VEGA Point 24 with the tube extension can be used to specify the sensor on the right length, which is going, for example, inside a tank. And last but not least, as mentioned, the VEGA Swing 51 as a vibrating forks. So these are our easier devices. Of course, we have also some sensors which are from our Blix series with the yellow housing, as you might know. Very interesting for the liquid food industry is also the IOLink communication, which is a very typical communication protocol right now, where we have some advantages. Rob will show you with our very last live demonstration what the advantage of the IOLink devices are in combination with an IOLink Master.
Yes, thank you. I have two devices over here connected to an IOLink Master. And one of the biggest advantages of an IOLink Master is that it will constantly compare the settings in the sensor to what it has stored inside of the IOLink Master. So if I make a change to one of the sensors, it will automatically upload those parameters inside of the IOLink Master. Should I have to change one of these devices, for example, due to a malfunction in one of these devices, the new device will automatically be uploaded with the parameters which are inside of the IOLink Master, saving you a lot of time. So the setup over here, we have my tablet connected to this sensor, which you can see because when I cover the tip, it turns to green, and over here you can see that the status is covered. Next to it, we have another sensor which is also in the same configuration, which is yellow for uncovered and green for covered. So we're going to say that this is the new device which we have over here. We're going to make some alterations to this device to make it really clear. We're just going to change the color, and those settings will be saved in the IOLink Master, and when I connect the new device, it should upload those data file into this device. So we'll go to Setup. And it's really easy. You go to Color, and we're going to say, okay, we don't want a yellow color, but we want, for example, a red color. So the status will go to red as uncovered, and it will go to green when it's covered. So those parameters has been written from the Bluetooth to the sensor. So now this event, for example, this sensor has a defect, and I have to change this sensor for a new one. So I disconnect the sensor, and I'm going to connect one of the new devices which hasn't been configured, and from the IOLink Master, the settings will be automatically transferred to this device. So now it's red for uncovered and green for covered, saving you a lot of time using this IOLink Master.
Perfect, Rob. Thank you. This was our final live demonstration. We are now already at the end of the webinar. We really hope you enjoyed it. So last but not least, thank you very much for your participation. We really enjoyed it.
Yes, definitely.
Hope you have a great day, and hope to see you soon for our further VEGA live webinars.
Thank you very much.